This problem is the most complicated of all that we have seen so far. So let's stare at the species that they provide us with for just a minute. Notice some important things about it. So first off, you see a sodium. That right there should be a big clue that we're dealing with something totally different. So sodium is a metal, and when it is in a compound with other nonmetals, what does that tell you? A metal plus a nonmetal equals a salt. The setup for this is pretty similar to the setup for a weak base problem. We just have an extra step to dissociate the salt. So let's move all this up here, write down what all we have to work with. We have our salt, which is sodium formate. This is a sodium salt, by the way. And if you were to consult your formula page, you would see that this is a completely soluble salt that dissociates completely, which is why we're giving it a single-headed arrow. Whenever you see something that is aqueous and has a single-headed arrow, you're not going to give it a variable, but we'll talk about that in a second. So we've broken that up into its two separate ions, and then we're going to take the formate anion and add that to water, and that's going to be a Kb setup. So remember your generic formula for that. You add liquid water, put it in equilibrium with hydroxide ion, and the conjugate acid. The third equation, as you are beginning to suspect, is the autodissociation of water. Let's assign variables. Again, we're going to ignore sodium formate because it's a completely soluble salt. We'll give that X. Sodium plus can be Z. And I'm just following along with the variables that the handbook is using. Call that X again. OH minus is H. Formic acid is Y. Proton is P, and OH minus is H. We can go ahead and get ready for our inputs, equations, and outputs. So the inputs that we know that Xi is equal to 0.25. We know that Yi over here is 0 because none of that has had a chance to form yet. One important thing to note is that Zi is actually going to be equal to the concentration of Xi because it's completely dissociated. Since we're working with a Kb reaction, you would expect to have easy access to a value of Kb, but if you don't, all you got to do is write down your value for Ka, which you can find in your handy chart, and then set up your equation for Kb. Remember that Kw is equal to Kb times Ka, so to solve for Kb, you just divide both sides by Ka. And then the last thing that we can input is Kw, of course, don't forget that. All right. Our outputs that we would like to know are x, y. For z, notice that we actually already know z. It's going to be equal to Zi because sodium is just a spectator ion. His concentration is not going to change. Let's put another happy star by that because that's a little scarily important. All right, moving on. We'd like to know P. And knowing H would be lovely as well. For our equations, equation 1 will just be our Kb setup. So that is H times Y divided by X. Our second equation, which we're going to need, is Kw per usual. Our third equation is going to be a charge balance. Let's see, let's look up here. Let's find all of our positively charged species. We've got sodium, we've got our proton. So our charge balance here is going to be Z plus P is equal to the sum of our negatively charged species, which are X and hydroxide, it looks like. So X plus H. And then finally, we're going to need one more equation since we have 4 unknowns, and our fourth equation will have to be a mole balance. Remember, we can't do oxygen or hydrogen, so how about we do carbon? That sounds like a good plan. So carbon, all the carbon, let's switch to a different color. Looks like it's coming from our original species, a little bit of that, some formic acid, and that's it. So when we write that out, we're going to have xi plus yi is equal to x plus y. Okay. You are now ready to plug into Mathematica, which will eventually spit out your value of P, which will then let you determine the pH. And I want you to remember that probably the most important part of this problem is the fact that there is an extra step, which is the dissociation of the salt step. So if you can remember your Kb setup and then add that initial step in, then you have it.